For lesson 5, we're going to talk about properties of logarithms, and we're going to apply some shortcuts to either expand logs or to simplify logarithmic expressions. And so applying these properties requires that we understand and know these properties. And again, these are rooted in the fact that when we are exploring properties of exponentiation, we learn a little bit about multiplying powers of like bases or dividing powers of like bases, taking a power to a power, etc. And so here are 3 properties of logarithms. There's the product property of logarithms that says log base b of a product can be broken down as log base b of the first factor plus log base b of the second factor. When we have a quotient, the quotient property tells us log base b of this quotient m over n, or m divided by n, is going to be found by taking the log base b, same base, of the numerator minus log base b of the denominator. And so this would allow us to take an expression and either expand it out or work it the other direction if we've got multiple things to put it into one single logarithm. That might help us with evaluating or solving, etc., etc. And then of course the power property of logarithms. Log base b of this power, m to the power x, is equal to, bring the exponent in front, x times log base b of m. And so essentially what we're doing here is we're understanding that this is the same as the product property. It's just condensing that thinking. So these are related to one another. So now we want to kind of explore that. We want to understand where we see these properties and be able to identify them. This 6 is the same as 2 times 3, all right? So log base 10, but log of 6 is equal to log of 2 plus the log of 3. This is a true statement, but this is demonstrating, this is showing the product property of logarithms, all right? What we have there is the log of 2 times 3 is the log of 2 plus the log of 3. Which properties are used here? Well, here we can see that we've got the quotient property because we're going to do subtraction, but also we can tell that we have the power property because we're putting this 2 in front of log base b of x. So first we are applying the quotient property, and then we are applying the power property. Now this is really important to understand what is coming first, the chicken or the egg here. Because if I apply the quotient property first, that will help us understand how to get that exponent down. I cannot put the 2 in front because it's not this x over y quantity squared. The squared, this exponent of 2 only goes with the x. So that's why we would have to break this apart as, and go ahead and let me write this and you go ahead and write it down as well. But I get x squared over y, and I'm going to show you the process here. We're going to write this as log base b, didn't say which base, of x squared minus the same base, log base b of y. Now we can bring that 2 in front, 2 times the log base b of x minus log base b of y. So this is kind of the step-by-step. Please include that in that example there so you can see that step-by-step. So what we're going to try to do is take these separated, in example 2, these separated logs and try to put them together if possible. Now what we should do to make sure that we can combine these is we have to have the same base. So here I've got base 10, base 10, base 10. This one's good. This is base E, base E, base E. We're good. Base 5, good. Base 4, base 4. Okay, so I can combine these logs into a single logarithm. And so this is going to be the log of 2 cubed, the log of 4, and the log of 16. Again, we're going to work left to right here. So I'm going to rewrite this as 8. And then I'm going to multiply these. This is going to give me the log of 8 times 4. And then minus the log of 16, which is going to give me the log of 32 minus the log of 16. Sorry for the handwriting. And then now I can write this as the log of 32 over 16, which we know is the log of 2. All right, so we took this kind of big, long expression, and maybe I showed a little more work than you would, but hopefully folks would write this, and then they would write that, and then maybe you would skip this step over to there, and then write this quotient, or maybe you would divide it straight away. And so my goal for you is to see all of the step-by-steps So as you're writing this down, in the margin, I want you to consider, oh, this part confused me, or this made 100% perfect sense to me. That's what I want for you to answer or ask yourself for letter A here. Did any part of this not make sense? Here, we've got log base 4 of 64 minus log base 4 of 16. So I can write that as log base 4 of 64 over 16. And we should know, or maybe we don't know, but we hopefully know that this is 4 cubed and this is 4 squared. And so 4 cubed divided by 4 squared is just 4 to the first power. So writing it as a single logarithm, this is our answer. But we know what log base 4 of 4 is. Log base 4 of 4 is 1. So if you answered this and you said 1, versus if you said log base 4 of 4, I would be okay with either answer. It did say to write it as a single logarithm, so this is what we're looking for. All right, but hopefully you understand that log base b of b is 1. I want for you to try this. Again, don't be confused because it's a natural log. Your calculator isn't going to do that work for you, but you should see each of the parts and pieces there. There's a little nuance here as we work this out from left to right that I want to make sure you do a good job with. All right, over here, log base 5 of x to the 6th power plus log base 5 of y. We're going to write that as a single logarithm, log base 5 of x to the 6th y. All right? Now, one thing that you may see, as we talked about in our last lesson, but that you might be aware of, is that you might need to, oceans of fun, or you might want to, write your expressions with parentheses. I don't see anything wrong with you doing that. It is a lot more writing of parentheses, but it might help you see that you're taking log base 5 of that whole product, x to the 6th y. Log base 4 of 4. You might find that valuable, although it is not expected or required. If you tend to get your things mixed up because your teacher has bad handwriting or you have bad handwriting, then I want to make sure that you're taken care of. All right, over here, let us expand out these expressions instead of combining like we did in the last slide. Now for example 3, we're going to be expanding them out. So here we have the log of y over 3 squared. So here I can put the 2 in front of this whole log of that quotient, which means that when I write this part as the log of y minus the log of 3, I need to have the 2 multiplier in front of the whole thing. All right, which means that this is 2 times the log of y minus 2 times the log of 3. All right, this is expanded all the way out, all the way out. I'd like for you to try that one. Here, I wanted to make sure that I did this because we have this 2 to the 1/2 power. And how do we want to handle that? Well, we're going to rewrite it as 2 to the 1/2 power. I think that might help us kind of see everything that's happening here. This is going to be the log base 5 of x plus the log base 5 of the square root of 2 minus the log base 5 of 3. Now this piece right here is what we're going to fix. We're going to rewrite that a little bit differently. So I've got the log base 5 of x plus the log base 5 of 2 to the 1/2 minus log base 5 of 3. And I'm going to put this 1/2 in front over here. So that's the only thing that's going to change. I've got the log base 5 of x plus 1/2 log base 5 of 2 minus log base 5 of 3. That's what we should have for our full answer. All right, so hopefully you did a great job with that. Again, off to the side in the margin. If there's anything that I did and you're like, that didn't make sense, explain that to me again, or better, Mr. Hibbett, then I can do that for you when we get to class. All right, and hopefully you did a great job with letter B and on letter C on the question before. So hopefully now you can kind of see and understand those properties, observe them and identify them so that you can apply them to either condense logarithmic expressions or to expand logarithmic expressions. This will be very useful for our next lesson when we are solving equations.